Hey guys, it's Miss Tortoise. I wanted to give you a quick tutorial about this problem of the week that's due on Friday. I know we went over it in class and we went through and we underlined important mathematical things, and then some of us even went through and circled what the question is actually asking. Like I said in class, there's many steps to this problem. The overall theme is that this person wants to plant basil to make a whole bunch of pesto. So we need to make sure that we are getting the maximum number of basil plants after a series of thinning, which is where you pull and get rid of some of the plants. The first thing we need to do is draw our garden, which is 15 by 10 feet. Through reading, we also find that this person's going to be planting marigolds and basil. And the marigolds she puts around the outside of her garden, a foot in. So all of these things along the outside in yellow, these will all be marigolds. They're a nice summertime flower, and in the reading it said that they attract good bugs and get rid of bad bugs. But what happens when you put those marigolds in is that instead of the full 15 feet across, we now only have 13. We lost 1 foot here and 1 foot here. So now this dimension of the garden is now going to be 8 because we lost a foot here and we lost a foot here. Now we need to be figuring out if we have 2 packets. 1 packet will give us 75 feet of seeds, so that means 2 packets will give us 150 because all we did here is just doubled. So now I got to figure out the number of rows and how many feet of seeds we can get. And when you go to plant seeds, it doesn't matter where we start, but for this way I'm going to start planting my seeds in one long row. So in one row I've planted 13 feet of seeds. And in the next row I've now planted 2 rows of seeds for a total of 26 seeds. You'll want to finish this ratio table a few extra steps to figure out how many you can do up through 150 feet of seeds. Okay, as you can see, I finished out my ratio table, and putting my plants this way, I've been able to do 7 rows using 91 feet of seeds. I still have a lot of seeds left over because I only used 91 and I have 150. But I had to stop there because I remember back in this third paragraph, the rows needed to be planted 1 foot apart. So that means if I need to plant rows 1 foot apart, I'm kind of limited in how many rows I can plant. So here's the area that I can plant just on a smaller scale. Here's my 8 and my 13. If I need to plant them a foot apart, that means 1 row goes there. I need 1 foot here before I start the other plant. And another row. So I need a foot in between each one. So 1, 2, 3, 4. Oh, I made my paper a little bit too small. 5. And then another foot. So I think I may only be able to get about 6 rows in this garden. So there's no need that I need to go to 7. So now I've got a smaller amount of rows, and now I need to go back through and figure out and break up the 13 feet by 2 to 3 inches, because now I only need a plant every 2 to 3 inches. And we're still not done. So go ahead and try this problem to see if you can figure out how many rows you can get, the maximum using 150 feet of seeds. Remember that problems of the week are designed to be very tricky, but that is okay. because when things are tricky, That means that we're using math practices to persevere, which directly helps you solve the problem because look, don't forget, those are two things that are in your rubric that you need to identify. So even if you're struggling, that's okay because you're still able to solve the problem. Make sure that you come into class on Wednesday with a specific question. Something that says, I got this, but I'm struggling on this. I got this part, I need help on. And have a great day off.